Hey everyone, and welcome back to WhyDecrypted, where we take the biggest mysteries of science and reality and try to make them a little less confusing. I'm Tom, your guide, your occasional mistake maker, and today we're asking one of those strangest questions that comes from physics. Every now and then, science throws up an idea that sounds less like physics and more like something from late night sci-fi. And are we living in a multiverse is one of those. What if our universe isn't the only one? What if in the entire cosmos we see, every star, every galaxy, every atom in your body is just one bubble in an endless cosmic foam? That's the multiverse. It's a concept so outrageous, it feels like it belongs in a comic book. And it is, in fact, in quite a lot of comic books. But it's also serious enough that real physicists write papers about it, argue about it at conferences, and occasionally bet their reputations on it. And the really weird part? If it's true, then somewhere out there might be another version of you watching another version of me making mistakes on this script. But it could be in a slightly different way. So let's start simple. Why even bother with the multiverse? Isn't this one universe of ours enough? After all, we can't even get our heads fully around this one. But here's the catch. The idea of a multiple universe doesn't come from boredom or from comic books. It comes from following our best scientific theories to their extreme edges. And when you do that, the equations don't stop neatly at one universe. They keep going. They start whispering. There might be more out there. And depending on which theory you're looking at, you end up with a completely different kind of multiverse. The first one we'll look at is eternal inflation, the cosmic bubble bath. Let's start with one of the most talked about versions. After the Big Bang, our universe expanded radically fast. In fact, some think it expanded faster than light. That's not breaking the rules, by the way. Nothing can move through space faster than light, but space itself can stretch as quickly as it likes. This brief period is called cosmic inflation. It smoothed out the universe, spread matter and energy evenly, and basically set the stage for everything that followed. But here's the twist. Some versions of inflation theory say it didn't stop. Well, at least it didn't stop neatly everywhere at once. Instead, it fizzled out in patches. In some places it ended, and a universe like ours began. In other places, inflation kept rolling, kept bubbling away. Each bubble became its own universe, sealed off from the others. And it was sealed off by ever-expanding space. And because space keeps inflating externally in some regions, this process never really ends. Hence the name, eternal inflation. So in this picture, our universe is just one bubble in an infinite cosmic bath. It's a nice metaphor, but let's make it more concrete. Imagine a pan of boiling water. That bubbles consistently. And as those bubbles grow, they grow and pop, and then up comes another one. Now replace the water with space-time, and replace steam with entire universes. That's the picture of inflation theory. And here's the kicker. Each bubble might have completely different physics. The strength of gravity could be different. The charge of the electron could be different. Stars might never form. Atoms might not even be stable. So in most bubbles, life would not be possible. In fact, they'd be dead on arrival. But every now and then, one bubble has the right mix of laws and constants to allow complexity, to allow stars, planets, and eventually people like us to form. So in this view, the fact that we're here at all isn't because the universe was designed for life. It's because we won the huge cosmic lottery. We just happen to live in one of the rare bubbles that could sustain life. Some physicists love this because it helps explain the so-called fine-tuning problem. Why does our universe look so perfectly balanced for life? Well, within a multiverse, the answer is this. Most universes aren't. We just happen to live in one that is. It's not designed, it's not a miracle, it's just statistics. Of course, others hate it for exactly the same reason. They argue that it's not science, it's just pushing the problem out of sight. If every possible universe exists somewhere, then how do you ever test that? And that's where the controversy really kicks in. Eternal inflation is elegant. It flows naturally out of the math, but it's also, so far, completely untestable. Still, the idea is seductive, because it doesn't just suggest a few other universes, it suggests an infinite sea of them, countless bubbles, each with its own physics, each forever out of reach. And if that doesn't make you feel small, then I don't really know what will. Now let's leave cosmic inflation behind and step into the strangest corner of physics, quantum mechanics. This is the land of uncertainty, where particles don't seem to have definitive properties until you observe them, where light can behave like a wave and a particle, where an electron seems to be in many places at once, well, at least until you measure it, and this all sounds confusing. That's because it is. Richard Feynman, one of the greatest physicists of the 20th century, once said, "If you think you can understand quantum mechanics, you don't understand quantum mechanics." And that's very true. And yet, despite the weirdness, quantum theory works. It underpins our computers, our phones, the lasers in your DVD player. If you still own one of those, that's very true, Ben. I haven't seen one of those for a while. The math is reliable. The interpretation is the headache. One way of interpreting it is the many worlds interpretation. Now, this was first suggested by a young physicist named Hugh Everett back in the 1950s. Everett looked at Schrodinger's cat, the famous thought experiment where a cat is both alive and dead until observed, and said maybe the cat really is both alive and dead, just not in the same universe. Every time a quantum event happens with multiple outcomes, the universe branches. In one branch, the cat lives. In another, the cat dies. In another, the cat escapes the box, learns to talk, and runs for parliament. Well, yeah, possibly. Well, yeah, definitely. Everett's point was simple, but radical. Quantum events don't collapse into one outcome. They all happen, just in different universes. Now, at first, almost nobody took him seriously. His own PhD supervisor reportedly told him to find a more sensible project. Believe it or not, Everett left physics not long after that and went into defence work. He died young, never seeing how big his idea would become. Because here's the twist. Today, many worlds is taken very seriously by a lot of physicists. It's not a fringe theory anymore. But sadly, Everett never got to see that. And why is it not fringe anymore? Because it removes one of the biggest mysteries in quantum mechanics, the so-called collapse of the wave function. In regular quantum theory, particles exist in multiple states until you measure them. Then, somehow, the wave function collapses into one outcome. But what collapses it? Measurement? Consciousness? Nobody knows. Everett's answer was, nothing collapses. All outcomes exist. The universe just splits. Simple, elegant, and admittedly completely mind-bending. If you take the many worlds interpretation seriously, it means that every time you make a choice, the universe branches. There's a version of you that took the job. Then there's the one that didn't. A version of you that moved cities. And the one that stayed. Even a version of you that clicked off this video 30 seconds ago. Every possibility exists. Meaning somewhere my channel is actually successful. Now, here's where it gets both thrilling and slightly unsettling. If that's true, then what does it mean to be you? Are you unique? Or are you just one of those threads among an infinite tangle of threads? Philosophers have wrestled with this too. If there are countless copies of you and I out there, each living out different lives, then do your choices still matter? Well, they do, but maybe not in the way we usually think. That can be a real identity crisis baked into the very math of physics. And of course, many worlds has leapt into pop culture. Marvel films, sci-fi novels, TV shows, where characters meet alternate versions of themselves. The appeal to this is obvious. Who wouldn't want to peek into the life where you made the other choice? The one where you stayed with that partner, or took that risk, or bought Bitcoin in 2011. And we're back to time travel. But here's the funny thing. The pop culture versions almost always get it wrong. They treat alternate universes as places you could visit, like taking a trip to another city. In real physics, those branches don't interact. They split and they stay split. You don't get to jump tracks, at least not with anything we currently understand. So as much as the Marvel Multiverse is fun, because it is, I'm sure a lot of us enjoy that, Everett's multiverse is colder. It's not about adventure, it's about inevitability. Everything that can happen does happen. It just doesn't happen for one version of us. Why it's controversial? Now, you might think, this sounds like nonsense. And you wouldn't be alone. Plenty of physicists hate many worlds. They argue it multiplies universes without evidence. It explains quantum mechanics, sure, but at the cost of filling reality with an infinite amount of impossible worlds. We can never test. Nobel Prize winner physicist Steven Weinberg once said he preferred it because it was mathematically neat. Others dismiss it as science fiction. And here's the real issue. We don't know how to prove it or disprove it. At least not yet. So just like eternal inflation, many worlds sits in that frustrating space between elegant theory and untestable speculation. But whether you love it or hate it, you can't deny it's compelling. Because it doesn't just change how physics works. It changes how we see ourselves. In many worlds, every possibility is real. Every road taken and not taken. Every mistake, every triumph, every what if. And that's both terrifying and kind of beautiful. So now we're going to look at parallel sheets, or brane cosmology. This one comes from string theory, which already asks us to imagine extra dimensions between the familiar three of space and the one of time we're already aware of. In string theory, our universe could be a massive three-dimensional sheet, called a brane, floating in a higher dimensional space. Now here's the kicker. There could be other branes floating right alongside ours. The entire universe is just a tiny higher dimensional nudge away. But we don't see them. Because we're trapped on our own brane like ants crawling on a sheet of paper. The ants can move left, right, forward, back, but they can't hop off the paper into the third dimension above it. In the same way, we're stuck in our own three-dimensional brane, blind to whatever else floats just beyond. Some versions of this idea even suggest that the Big Bang itself was caused by branes colliding. Imagine two cosmic sheets slamming together, dumping energy and creating a brand new universe in the process. One way to explain why the universe began so suddenly with such energy is this. And here's the eerie bit. If that's true, then universes could keep being born, over and over whenever branes bump into higher space. A cosmic traffic jam we can't see. But we could feel the aftershocks. It's a wild thought. And like the others, it's elegant, specifically in the math. But it is impossible to test in the lab. Now let's look at mathematical universes. And this is getting even more abstract. Some physicists and philosophers argue that mathematics isn't just a language we use to describe the world around us. Instead, mathematics is the world. According to this view, every consistent mathematical structure exists in a real universe. That means our universe isn't special. It's just one example of equations running. Somewhere else, another set of equations is running, making a different reality. In one, maybe there's no matter, only energy. In another, maybe time doesn't move forward, it loops. And in yet another, maybe causality doesn't even exist the way we think it does here. And of course, in at least one of these mathematical universes, Ben finally hands in a script on time. But not this one. Definitely not this one. Or maybe in one of these universes, Ben actually hands in a script that's the right one, because this is not the script I thought we were doing today. But it is the one we've got, and it's so far very good. So why do physicists care? At this point, you might be asking, why do serious scientists even bother with this? Isn't it just daydreaming? But here's the thing. Each version of the multiverse solves a problem. Eternal inflation explains why our universe looks so smooth and uniform when it shouldn't. Many worlds removes the mystery of the wave function curves. Brane cosmology offers new ideas about how the Big Bang could have started. Mathematical universes answer the deep questions. Why are the laws of physics so suspiciously mathematical? In other words, these aren't just what-if fun questions. They're attempts to make sense of a puzzle that our universe has dumped in our laps. So that brings us on to the evidence problem. And this is the thing we keep running into. So far, we don't have a smoking gun for any of this. Some physicists think if another universe brushed up against ours early on, it might have left scars in the cosmic microwave background. That's the faint afterglow of the Big Bang that we can detect. The only problem with that is that we've looked, and so far, there is nothing clear. Others wonder if black holes are gateways. Maybe when matter falls into a black hole, it bursts a new universe elsewhere. That would even explain how our own universe started. But right now it's just speculation. I think we did a video on black hole universes. And many worlds, by definition, those other branches don't interact with ours, which makes testing it almost impossible. So all of these ideas live in a frustrating middle zone. They flow naturally out of the theories, but we can't test any of them. So let's look at the history of this. It isn't entirely a modern obsession. Humans have wondered about other worlds for thousands of years. The ancient Greek philosopher Democritus suggested that an infinite number of worlds might exist, some with life, some without. And in the Middle Ages, philosophers argued about whether God could create more than one world. And in the 20th century, as soon as we got serious physics of the very small and very large, the multiverse idea snuck right back in. So in a way, this is just the modern face of an ancient itch. What if our reality isn't unique? So let's play the thought experiment. Suppose the multiverse is real. What does that mean for you and me? In infinite universes, every possibility exists. A world where dinosaurs still roam. A world where Earth never formed. A world where humans mastered space travel centuries ago. And yes, a world where you decided to watch literally anything else right now. The multiverse might even explain why our universe seems fine-tuned for life. If there are countless universes, most are duds. A few just happen to work, and of course we live in one of those. But here's the biggest question. If there are other versions of you out there, what does that do to your sense of identity? Are you unique? Or are you just one addition in an endless cosmic library? It's thrilling, it's terrifying, and it's one of the deepest questions science has ever dared to ask. That actually reminds me of a book I read not long ago. I think it's called The Midnight Library, and I can't remember who it's by, but I will put it in the comments below because I highly recommend that book. It was very, very good. So let's close this. Do we live in a multiverse? Right now, nobody knows. It might be the deepest truth about reality, or just a grand illusion of our equations. But here's the itch that keeps physicists up at night. If other universes are out there, could we ever reach them? Are we sealed forever inside this bubble, staring into an ocean of possibilities we can never touch? And if there really are infinite universes, is there one where Ben can meet his deadlines? Well, thank you everybody for being here. This has been WhyDecrypted. I've been Tom. Script was by Ben. When you see this, it will have been edited by Max. And yeah, please remember to subscribe and like, because nothing is quite what it seems.